Welcome to section 7.3, define and use zero and negative exponents. Now, one thing that we can think about as we are talking about power. So let's say we've got like 2 to the first and 2 squared and 2 to the third. Just looking at patterns, 2 to the first we know is just 2, 2 squared is 4, and 2 to the third would be one more 2 multiplied in, so that's going to be an 8. So as we increase in powers, what happens to our numbers? Well, they multiply by 2 because we have a base of 2. Well, can we follow the same pattern in the opposite direction? So as we decrease in powers, what happens? Well, to get from 8 to 4, we divide by 2. And to get from 4 to 2, we divide by 2. So if we were to then project and just guess as to what happens when we go for a 2 to the 0 power, well, that just means you're going to divide by 2, and 2 divided by 2 is 1. And this is actually the property that is true for anything being raised to the power of 0. Anything to the power of 0 comes out to be 1. Because it's essentially saying, what is that number when it's divided by itself? So 2 divided by 2 is 1. 8 divided by 8 is 1. Negative 51 divided by negative 51 is 1. Fish divided by fish is 1. If you have a really cute drawing of a dog and have a dog raised to the 0 power, it's still going to be 1. Doesn't matter what your thing is, anything to the 0 power is going to come out to be 1. Now, can we follow that pattern further than to figure out what the heck the negative exponents end up doing? Because, if you notice, we're going to be working with negative exponents. And that very next problem involves a negative exponent. Well, if we keep dividing by 2, or going down by a power of 1, we'll have 2 to the negative first. It's then going to be 1 divided by 2. And then 2 to the negative second will be 1 divided by 2 divided by 2, which, if we turn that into 2 over 1, we can then flip and multiply our fraction. So 1/2 times 1/2 is going to be 1/4. And then 2 to the negative third, we divide by another 2, which would be the same as multiplying 1/4 by another 1/2, which will give us a 1/8. So what pattern can we see here? Well, our numbers down here, 1/8, 1/4, 1/2, these are just the reciprocals of 8, 4, and 2. So when we get to a negative exponent, we can actually get rid of that negative exponent by just taking the reciprocal of the number. So a to the negative n would be the same as 1 over a to the positive n. So let's go and use both of these tools in practice. So 3 to the negative 2, well, to get rid of that negative exponent, we just take the reciprocal, and so it'd be 1 over 3 squared. Negative 7 to the power of 0, anything to the 0 power, we know is 1. Let's see, 1/5 to the negative second, we would need to take the reciprocal of that. So that would then make it a 5 over 1 to the positive second, which would give us a 5 squared over 1 squared, which would be just 25 over 1, or in other words, 25. Now, 0 to the negative 5th. Well, 0 is the same as 0 firsts, so when we take the reciprocal of that, we're going to get a 1 over 0 to the 5th. But we can't divide by 0. Even in fractions, when we're taking the reciprocals, we can never divide by 0. So, this one has no solution, because we can't have 0 in the denominator. So let's try some other ones. And now we're going to actually go back to the last couple sections and take some of those properties in as well, so we can just start pulling it all together. So 6 to the negative 4th times 6 to the 4th, we have the same base, so we can just add their exponents. So negative 4 plus 4 is going to give us a power of 0, and anything to the 0 power is 1. let's see, for this next one, 4 to the negative second squared, we can multiply our exponents together and we'll come to the 4 to the negative fourth, which would be the same as 1 over 4 to the fourth. You might have also been thinking, oh, let's start from the inside out. And so we'll go, and we'll say that 4 to the negative second, well, that's going to be the same as 1 over 4 squared. And then that's going to be squared. Well, then we can multiply those exponents and we'll get a 1 over 4 to the fourth. So you can actually do it either way and you will still get the same answer. Now, 1 over 3 to the negative fourth, to get rid of that negative, we have to take the reciprocal, and we'll get a 3 then to the positive fourth. For this last one, there's a couple ways you can do it. First, whoops, come on back. There we go. First way you can do it is think about, oh, we'll just follow that same property, and so we'll take the same base, and then we'll take the top power and subtract the bottom power. So 5 to the negative first minus 2 will give us 5 to the negative third, be the same as 1 over 5 to the third. The other way you could think about doing this is get rid of that negative power first and just take the reciprocal of that, which would then give us a 1 over 5 to the first times 5 squared, in which we can then add our exponents together and we'll get a 1 over 5 to the third. So you can do it either way, whichever makes the most sense to you, but you will still come up with the same answer. Now let's go ahead and simplify some more complicated looking expressions. So first thing I'm going to do with this first one is I will distribute that power of 3 into each part. So we'll have a 2 to the third, x to the third, y to the negative 5 times 3 will give us a negative 15. So now to get rid of that negative exponent, because the proper way to write these is only using positive exponents, we need to flip that y to the other side. So we will have, on the bottom, we'll now have the y to the positive 15th. And on the top, we'll have 2 to the third times x to the third. Now let's go and try another one that looks more complicated. So just like last time, I will start out this time distributing that negative 2 into both parts. So we'll have a 2 to the negative second, x to the negative second, y to the fifth, over negative 4, x squared, y squared. Well, when doing it this way, you can now have, well, no, not you can now have. We will want to bring these negative exponent parts to the other side to make them positive. So that means you'll be left with a y to the fifth on top. And on the bottom, we will then have a negative 4 times x squared times y squared times, we'll then have a 2 to the positive second power and an x to the positive second power. Well, now we can go about starting to simplify things. So our y to the fifth on top and our y squared on the bottom, we can go and subtract our exponents, and we'll get a y to the 5 minus 2 is 3. So that will be left on top then. On the bottom, we'll still have that negative 4, and that can be multiplied by 2 squared, which is a positive 4. And then we can also then combine our x's. So x squared times x squared, you add those exponents together, 2 plus 2 is 4. And last thing we can do is we can multiply the negative 4 times 4, which will give us a negative 16, x to the fourth on the bottom, and then a y to the third on top. So that's all the more I've got for you for today. So good luck, and let me know as always if you have any questions.